In this video, we are going to be focusing on mixtures. So we'll be looking at mixtures and figuring out what they look like and what their properties are. So a mixture is a combination of two or more different substances. Now remember, a substance can be either an element or a compound. So we could have two or more different elements. We could have two or more different compounds in order to be a mixture. We could have an element and a compound in order to be a mixture. Now, the key to picking out a mixture is that no bond is formed. So in this first diagram here, this one is going to be a mixture of two different elements. So we've got red element, we've got blue element. They're both in there, but notice they are not connected. So because they do not have a bond, no chemical change occurred. So they're actually going to keep their original properties. This second diagram over here, we have one type of compound here, and then we have a different type of compound here. So this second diagram shows us a mixture of two different compounds. Now, since no bond occurred between the two parts, there was not a chemical change, so the parts will retain their individual properties. So if we take sand and iron and mix them together, they would just be in there together. They will both keep their individual properties, so the iron would still be magnetic. So the parts can be separated by physical means. So if we had the sand and the iron is magnetic, so we could pull the iron out with a magnet. So you can separate them by physical means. So much easier to separate the parts of a mixture than the parts of a compound, because that requires a chemical reaction in order to do that. So you could filter a solid and a liquid. Distillation is a separation based on boiling points. So if you have two liquids that mix together, you could boil them, and the one with the lower boiling point would boil off first, leaving behind the second one. So it's a separation based on boiling point. Density, so things can layer out, and chromatography, which you should have talked about in living environment, like you probably did the lab where you put the dot of the marker on the piece of paper and then the different dyes separated out based upon their polarity. And we'll talk more about that later on in the year. Mixtures can combine in varying ratios. So if we have salt water is a mixture of salt and water. You could have a little bit of salt or a lot of salt. So we can vary the ratio in a mixture. Mixtures can be either heterogeneous or homogeneous depending upon the mixture. So hopefully you remember, elements are always homogeneous, compounds are always homogeneous. Mixtures can be either or depending upon the mixture. So for example, if we take the air that we breathe, that is a mixture of a bunch of different gases. It's about 76% nitrogen. Then we also have oxygen, some carbon dioxide, water vapor. So you have a lot of different elements in there, a lot of different compounds in there, but you cannot see them. It appears uniform, therefore it is homogeneous. Another example of a homogeneous mixture are aqueous solutions. So aqueous solutions are solutions that are made with water. So if you see a little AQ next to something, that means that it has water in it. So NaCl is going to be salt dissolved in water. So when you dissolve salt in water, you can no longer see the salt, but it is still there. These also help to illustrate some of the other properties that we talked about, like the parts retain their individual properties. So if you have salt water, it will still taste salty. So the salt still acts like salt. Some heterogeneous mixtures would be a chocolate chip cookie. You can see the chocolate chips, you can see the dough, and it's not going to be in there uniformly throughout. All right, just like in the last video, I would like you to pause this and come up with some similarities and some differences between our compounds and our mixtures. All right, as you can see, I kind of ran out of space on this one. So here's my similarities, and my differences went up and down. So our biggest difference is what they are composed of. So compounds are composed of two or more elements that are bonded together. Mixtures contain two or more substances that are not bonded together. You could have made that into two differences. Since our compounds are bonded together, they require a chemical reaction in order to break them down. Mixtures, since they don't have a bond between the two parts, just require a physical change to break them down. Our compounds are always homogeneous since they are a pure substance. Mixtures can be either homogeneous or heterogeneous because they are not a pure substance. In compounds, your parts are combined in a definite ratio. So something like water has to be 2 hydrogen to 1 oxygen. Whereas when you have a mixture, the ratio may vary. So if you had a mixture of hydrogen and oxygen, you could have any amount of the two. Then up here on the top, when we have a compound, a chemical change occurs, which makes the parts get new properties. So we talked about that, hydrogen and oxygen combine to make water, they get new properties. When you make a mixture, a chemical change does not occur, so therefore the parts keep their original properties. Then with our similarities, they both contain two or more different parts. They both can be broken down in some fashion, and they both can be homogeneous.